So your exponential functions. Our parent function looks like this. F of x equals b to the x power. And b is a number. X is the variable. Okay? That's the base of your exponential. If the base of the exponential is greater than 1, okay, so if it's greater than 1, the function is an exponential growth. And is increasing, hence the growth part of that. Okay? Exponential growth and is increasing. So it would look something like that, right? If b is less than 1, and really, depending on how you, it's not going to be negative, so really it should be between 0 and 1. The function is an exponential decay. And is decreasing. Now, there's other ways we could get it to decrease and whatnot, but when we're talking just purely the parent function, just a very basic exponential, this one would look like this. Well, shoot, something like that. So if my base is, let's say my base is 2. I have an exponent. No matter whether my exponent is positive or negative, it's not going to change the sign on the base, right? So if my base is a positive number, no matter the exponent, my output is positive, which means I'm not going to get to 0, and I'm not going to have negative numbers. That's why we have an asymptote, which again should not be brand new to you. Depending on what class you're in, depends on how much you've talked about them. So this is what I was just talking to Mr. Ackerman about, was like, how would you define it at this level? Because unfortunately, I think a lot of people get taught that an asymptote is a line that a function approaches but never intersects. And that's not necessarily a true statement. If you have a vertical asymptote, you can never cross that vertical asymptote. If you have a horizontal asymptote, you can in some instances. And so I just want you to know that it is possible. When we're talking about these exponentials right now, we're not going to, but that just kind of changes how you write this down in words. So we're just going to say that an asymptote is a line a function approaches, because that's still a true statement no matter what kind it is. So here's what we're going to do to make this super basic. And what I have found, and what I think sometimes you get too involved in these functions trying to figure them out on a standardized test, and you're not sure where to go with it, and you try and substitute in numbers, and you got all kinds of crazy numbers going on. Now stop drawing and pay attention. You need to be able to think just in general what this looks like and what's going on here. So if I set up each time, now this is the parent function, and even though this is a 2, this is a 3, these are still parent functions because there's no transformations. Transformations are not brand new to you either, so I haven't shifted it left, right, up, down, stretched it, whatever. But with an exponential, the base can change. It's still basically a parent function. So I'm not necessarily going to write this every single time, but we'll do that for a few times. We're going to pick x's, -1, 0, and 1. And I don't think you'll need to write this every time, but I want to make sure you know where I'm getting the stuff. So if I substitute in a -1, what is 2 to the -1 power? 1/2. Very good. See, we paid attention yesterday. All right, what is 2 to the 0 power? 1. And 2 to the first power? 2. Okay, so I sort of got off on there. But see, very easily, right? And again, we don't necessarily have to write the t-chart, but I don't want to lose anybody. So if I plot those 3 points, at -1, I'm at 1/2. At 0, I'm at 1. At 1, I'm at 2. That gives me enough to understand my function. Now remember, this is the parent function. We have moved it left, right, up, down, anything like that. So no matter what the exponent is that I put in here, I'm not going to get 0. If I can get a really, really small number, get really close to 0, but I'm not actually going to make it. So I have this asymptote. Well, that's big, but I have this asymptote here at y equals 0. So I can't cross that. And then we're going to sketch this, just kind of the best we can here. Now, on the TSIA, on the SAT, you're not going to have to graph these. They're not going to give you a grid and you have to make this perfect graph. But understanding what's happening here can help you reason through the rest of the stuff, okay? So let's talk domain and range and end behavior. Is domain X or Y? X. So are my X values restricted at all here? No. Can I use all the X's from negative infinity to infinity? Yes. So we could say that that's all real numbers, but we also need to practice on interval notation. So negative infinity to infinity. Do I get to use all of the Y values that exist? No. And make sure you're going left to right, bottom to top, least to greatest. So I don't get to use negative 10 or negative infinity, but I can use something right on the other side of 0, which means I can start at 0 and go to infinity. You never include the infinities, and in this case, would I include the 0? Can Y be 0? No, that's why I have an asymptote there, right? If I'm not going to get an output of 0, so I'm not including it. 0 is not a Y value that's on my graph. Okay? Now, the concept of end behavior might be kind of new to some of you, but that's okay. We're talking literally at the ends, way out at the infinities, right? This means as x approaches infinity. So as x gets bigger and bigger and bigger here, what is f of x, the y values, what's that going to go to? Approach. Where we go? The x is 0, not the y. That's an x value for the range. Oh, because it can be just right above 0, but I didn't include it. If I did this, that means it can be 0. Since it's open, I can't include it. It's like saying that y has to be greater than 0 and not greater than or equal to. Anything greater than 0. Is that what you're asking? Okay, good question. Everybody else good on that? Thank you for stopping me. All right. Now, so we're good on that, right? And that's actually like not what it is. It's not. All right, so as x gets bigger and bigger and bigger and is heading towards infinity, what are your y values heading towards? The y values are getting bigger and bigger and bigger. Where are they heading to? Infinity also. Yes, good. Now, as x approaches negative infinity, as x is getting smaller and smaller and smaller, your y values, are they going to approach infinity? No, I have this asymptote, so what are they approaching? 0. Okay. Your y-intercept, so we don't want to guess off a graph that we sketched, but we actually plotted a point, right? So do we have that? What is it? 0, 1? Asymptotes are lines, so they need to be written as equations of lines. This is horizontal, so it's y equals what? 0. We good on that? All right. Let's go to this next one, and we'll do the little T-chart here, and then we'll just start talking through some of the other ones. So I've got x and y. Negative 1. I'm going to space them out better so I can write better. So what is 3 to the negative 1 power? 1/3. Good. What is 3 to the 0 power? 1. What is 3 to the first power? 3. We all agree with those? I think those are easy numbers to come up with, right? No matter what the base is. So I'm going to plot those 3 points. I've got negative 1, 1/3, which, you know, that's just the best you can do on these little things. You just do the best you can. 0, 1, and 1, 3. On this board, I can't always hit where I'm trying to aim. Now, again, I haven't shifted it up, down, left, right. I know it's exponential, so I have a horizontal asymptote here at y equals 0. And then I'm just going to do the best I can to sketch in my graph, what did I do? Oh, that is 1, 4. Good Lord. helps if I could count, huh? Yes, 1, 3. There we go. I think when I was so worried about trying to hit it where it crossed, I wasn't paying attention to what number it was on. All right. Then I have my horizontal asymptote, and then I can just draw this in the best I can. It's not an art class, but we want to make an honest effort, right? What's my domain here? Negative infinity to infinity. What's my range? 0 to infinity. Good. Never include the infinities, and I'm not including 0 because my asymptote means I'm going to get really, really close, but I never actually make it there. Okay? As x approaches infinity, what does f of x approach? Infinity. As x approaches negative infinity, what is f of x approaching? 0. What's my y-intercept? 1, so 0, 1. My asymptote is at y equals what? 0. Now look at what we did for these. These had different bases, right? 1 was 2, 1 was 3. Everything we just filled out in that chart, is any of it different? No. Without the transformations, nothing's different. The only thing that's different about the graphs is that this is at 1, 3, where this, these 2 points are different. Obviously, the other points are different. But as far as this important stuff, the same. The most important thing, I think, is for you to remember and understand that the y-intercept of an exponential parent function is 1, because it would be whatever number is to the 0 power, and that's always going to be 1. Okay? Does that make sense to you? That's a connection you need to make here. So when we look at this one, all right, well, let's go ahead and we'll make a chart on this one too, just because it's a fraction. Those were exponential growth. This is exponential decay, right? So we're expecting it to look like that. Would you agree with that? Yeah, 1/2 is less than 1. Yep, that's why, yes. And so I'm still going to do -1, 0, and 1. So what is 1/2 to the -1 power? 2. What is 1/2 to the 0 power? What is anything to the 0 power? 1. And then 1/2 to the first power is 1/2. Okay. So I'm going to come over here. I've got -1, 2. Hopefully I can hit the right ones here. 0, 1, and 1, 1/2. I still have a horizontal asymptote at y equals 0. And then I can sketch in my curve that looks something like that. So my domain, still negative infinity to infinity. Would you agree with that? My range, is it still 0 to infinity? Yep. Now in behavior is going to change up a little bit. As x is approaching infinity, what is y approaching? 0. As x is getting bigger and bigger and bigger, the function's approaching the asymptote, right? Which makes that 0. As x is getting smaller and smaller and smaller, we're going to the left. Y is approaching, well, the y, as x approaches negative infinity, yeah, the y value is approaching infinity. Okay. What's my y-intercept? 0, 1. Because anything to the 0 power is going to give you 1. And then my asymptote is at y equals 0. You got the hang of that? All right, so let's look at number 4. Let's try to not write the stuff. Well, maybe we still need to write it out just because I don't want you to get flipped around on these fractions. Well, oh, that's fine. X and f of x, I keep them right next to 1. I'm still going to choose -1, 0, and 1. Those are my anchor points, all right? So what is 2/3 to the -1 power? Three over 2, because we do the flippy thing, right? Weren't you the one that told me the flippy thing yesterday? It's the reciprocal, 3 over 2. 2/3 to the 0 power is 1. 2/3 to the first power is 2 over 3. So when I go to graph these, well, first of all, is this exponential growth or decay? decay because this is less than 1. So it should look like this. If it doesn't, I did something wrong. So at -1, I'm at 3/2, which is like 1.5. Then 0, 1, and then 1 2/3, which, my points are big. It looks good. I still have my asymptote here, and I'm going to sketch this in. So what I want you getting out of this right now is the fact that your y-intercept is 0, 1. It's going to cross at 1, no matter what, without transformations. The other thing is how to get these 3 anchor points without it really just messing with your brain. My domain is the same here, -infinity to infinity. My range is still 0 to infinity. As x is approaching infinity, what is y approaching? 0. Good. And as x is approaching -infinity, what is y approaching? Infinity. Good. What's my y-intercept? 0, 1. And where's my asymptote? Y equals 0. Yep. All the decays are going to be the same. The only thing that changes between growth and decay is the end behavior. The rest of the stuff, the domain, the range, all that stuff is the same. All right. Number 5. Is this growth or decay? Growth, because it's a fraction, but it's greater than 1, right? So it's going to look like this. So we'll go ahead and write these down. I'm going to do -1, 0, and 1. What is 5/2 to the -1 power? 2 over 5. What is 5/2 to the 0 power? 1. What is 5/2 to the first power? 5 over 2. Right? So I'm going to plot those 3 points. -1, 2/5. It's a little less than a half. 0, 1. Shocking, right? And then 1, 5/2, which is like 2.5. I still have my asymptote here. And this is what my graph will look like. So when is this function negative? When is the function itself negative? Is it ever negative? The graph? The graph, I don't have any negative y values and it can't be 0, right? So it's negative, it's never negative and never equal to 0. So we could write the same thing again, -infinity to infinity. Range 0 to infinity. For this one, as x is approaching infinity, what is y approaching? As x gets bigger and bigger and bigger, y is approaching infinity. Good. And as x gets smaller and smaller and smaller, y is approaching 0. My y-intercept is 0, 1. That doesn't look like a 1, but 1. My asymptote is still at y equals 0. Now, this was without any transformations, but we need to know all of that so that we can then understand what's happening with the transformations. Okay? We good so far? All right. So we're going to talk about transformations today, but we'll graph them tomorrow. So I just want to start part of this, and then we don't have to cram all this in one day. So when you learned transformations, now again, you start learning them in Algebra 1. You do talk about transformations in geometry. Whether or not you talked about them algebraically, I guess it probably depends on who your teacher was. You should have, but, you know. And then you definitely do it in Algebra 2. But you can use different variables. So some people teach it with P, Q, R, and S. I prefer A, B, C, and D. This has H and K on it, and I left it that way because, who knows, when you take college algebra, maybe that's the last math class you have to take for the rest of your life. But even in there, I don't know how that professor is going to talk about transformations, because you can do it. It doesn't really matter what the letter is. It's what the letter is doing, like where it is. And if you move on to other classes, that professor might be different than the last professor. So it's kind of good, I think, as long as it doesn't confuse you, to see it a couple of different